right, people. Algebra 1, Section 9.3b, we're talking about vertex form of a quadratic. Okay, so far going into this thing, we've talked about one equation of with quadratics in 9.1, basically. And now we're going to talk about the second one. So the first one, we know this one, y equals ax squared plus bx plus c. We know that one for sure, okay? And we kind of discovered that there's another form in our project that we did, and that's kind of the objective today is we're going to take quadratics from standard form and put them in vertex form and identify the characteristics of that. That's the idea, the objective of this section. So vertex form is in this form. We've got y equals a times x minus h squared plus k, so a little bit different. And we got a couple different variables, and we'll explain what those are going forward. Okay, so we kind of talked about this, and we did the project transformations of quadratic equations, quadratic functions, and we kind of talked about transformations in the first half of this section. So the first one is a translation, horizontal translation. And this one is dealing with your h value. And remember, we're talking kind of the absolute value of h, or if you go h units to the right if h is positive, and to the left h units if h is negative. And remember, this is the one that you got to be careful with, and you got to watch the sign. And kind of you're ignoring that minus sign in there because ax minus h. So just be careful with that. Whatever way it helps you to think about it, maybe do the opposite of what's in the parentheses, or if you just can ignore the minus sign and take it as a positive, negative there, you're just looking at the h value. But that's going to translate it horizontally, left and right, depending on your h value. A vertical translation over to the right here, that one is when we're going to go translate it up and down, and that's based on your k value. So those are the two numbers, or two letters, two variables that we have in vertex form. Remember, here's your vertex form. I know it's small up there. I know a lot of the writing here is small, but you just got to kind of do the best you can with it. But so using vertex form, we can know automatically which way it's going to slide left and right with h, and over here on the right, which way it's going to slide up and down based on your k value. We also talked about reflection down here on the bottom left. That is, if a is greater than 0, the graph opens upward. If a is less than 0, then the graph opens down. So that's just based on your a value, whether it's positive or negative. And a dilation is based on your a value, and this is if it gets stretched vertically or compressed vertically. So if the absolute value of a is greater than 1, then we stretch it vertically. And what does it mean by stretching it vertically? It means that it's more narrow. It means it's more narrow. And then if we have it compressed vertically, that's where it gets wider. So like this green one here, this one is definitely compressed wider, compressed vertically, where this red one might be stretched vertically. So stretched vertically means it gets more narrow. Compressed means it gets wider. Okay? And that's based on your a value. Again, if your a is greater than 1, then it's going to make it more narrow. If it's between 0 and 1, like a fraction or a decimal, then we would have it be wider. Okay? So let's talk about up here what we know over to the right now. So the first thing, we know that the a value deals with a dilation. It also deals with your maximum minimum, which way the graph opens up or down. H and k, so the beautiful thing about vertex form now, and that's the same as it was in standard form, but h and k in vertex form, now we know that is actually the coordinates of our vertex. So before we had to kind of do some work for it, negative b over 2a, and now if you're in vertex form, you know that your vertex is going to be h and k, those actual variables, those numbers are going to be your vertex. X equals h now is going to be your axis of symmetry. So again, before you had to do minus b over 2a, but if you're in vertex form, you can take your h value. That's simply the axis of symmetry in that case. Your c value, that's still going to be your y-intercept. So when you are, if you're in standard form, remember, then then we can take our C value right away if we're in standard form. So when you're kind of working from standard form to vertex form, don't forget about your C value in standard form. You can get your y-intercept right away, and that helps you with one of the points. Your domain's going to be pretty simple as well, because we can always use all reals, because you can kind of pick your x values. Your range is probably going to be the hardest one. And basically, you just have to look at the graph and or look at your table and see what the range of values is. So your graph or your XY table and see what the range is, okay? So your domain is going to be all reals. That's pretty easy. But for example, let's take a look at this bottom right one here. We know the domain's all reals, but what would the range be? So in this case, our range, well, if we take a look, that's your y values. Remember, we wrote it y such that, and then what are your y values? So if you take a look at it, there is nothing below the x-axis. In fact, that's the lowest it goes. There's nothing down here. Everything is going up from 0. So in this case, we'd have to say y is greater than 0. And that would be our range, okay? Because all the lines are above the 0 point. Now, if you did that, like, say, down here, for this green one, let's take a look at this graph right here, okay? This one's a little bit lower than 0, okay? So our range here would be y, such that y is greater than -2, right? Because we're at -1, -2 here. So wherever the lowest point is, basically if it's a minimum, you can do that. And the same thing if you flip it around, if we got a maximum point, okay? So the range is the toughest one, but you'll get the hang of it just by looking at the graph. Or you can look at your XY table. All right. So let's talk about how we turn standard form into vertex form. How do we do that? Okay. So the first thing we're going to do is you're going to start with standard form, and we want to identify our A, B's, and C's. Okay. So that just helps us with some things. Then what we're going to do is we're going to actually scooch C over and put parentheses around the first half of the problem. Yes, scooch, that's a technical term. So we're going to move your C value over and then put parentheses around the first half of the problem. So let me just show you that in terms of standard form. So if I said standard form here is y equals ax squared plus bx plus c, okay? So what I'm going to do now is I'm going to actually take this c part, I wish I could take the c, and I'm just going to kind of scoot it over and leave some space here because I'm going to actually have to put something in that spot, okay? And I'm going to put parentheses around the rest of the problem. So I'm going to go here, and I'm actually going to give some room because I'm going to actually put a number in this spot here. Okay, so I'm actually going to put something here, and I'm actually going to put something over here as well. We'll get to that in the next step, okay? So all I did there is I just moved my C value over a little bit and then put parentheses and gave myself some room for the next step. So now I'm going to find half of B and square it. So I'm going to take B and I'm going to divide it by 2, and then I'm going to square it, okay? And that is what's going to go here in the next part. You're going to add this value to the inside of the parenthesis and subtract it on the outside of the parenthesis. Okay, so after I take half of B, so I'm going to take this B, divide it by 2, and then I'm going to square it. That is going to go here. I'm going to add it there, and then I'm also going to subtract it over here. Which we'll kind of talk about that. You're adding something, and then you're subtracting it. Well, you can do that in math. You can add something as long as you subtract it, because then it equals out. Okay, and you'll understand why once we use some real numbers. Just follow along at this point now. And then write the trinomial as a perfect square trinomial. Or excuse me, perfect square binomial. Okay? So again, the key are these last 3 steps here. Find half of B and square it. So you're just going to divide your B value by 2, and then you're going to square that value. Then you're taking that, you're adding it to the inside, but you're subtracting it from the outside of the parenthesis. That's important to know, because if you add something, you have to make it equal, subtract it on the other side. Okay? You'll see, like I said, you'll see when we do some problems with real numbers. And then the final thing is writing the trinomial as a perfect square binomial. Now you can factor it, but we could also use a nice easy factoring shortcut here with using the perfect square, because we're actually going to always have a perfect square trinomial, which then we can write it as a binomial. Okay, which again you'll see as we move through it, the examples. All right, so let's take a look at this first example. Write y equals x squared minus 10x minus 8 in vertex form. So it's in standard form. We want to write it in vertex form. So the first thing I'm going to do is I'm going to just identify my A, B's, and C's. And now you don't have to do it. You don't have to do this step. I just like to do it to know, so I know what they are. It just helps me moving forward. So my A value is 1, my B value is -10, and my C value is -8. Okay? And then, so now my next start is I'm going to scooch that C value over. So I'm going to take this equation here, and I'm going to rewrite it, but I'm going to move that -8 over a little bit. I'm scooching it over. So I've got y equals x squared minus 10x, and I'm going to give some space and put my -8 over here. I'm just going to do this in black here just so I can use a different color. So again, x squared minus 10x, I'm moving it over and putting a -8 over here. Okay? All right, the next step, and then I got to put parentheses around my first two. So I put parentheses here, and I got parentheses here. Give it some space because I'm putting a number in there. All right, the next step is to divide my B value by 2 and then square it. So if I take my B value, I'll just do this work over here. My B value is -10. So I'm going to take half of it. That means divide by 2. So when I take -10 divided by 2 gives me a -5. Then I'm going to square that -5. A -5 squared gives me a +25. And I'm going to put that +25 in here. Okay? I'm also going to put that +25 on the outside, but I'm going to subtract that value. Okay? Move this out of the way. Because think about that, if I can add 25 and subtract 25, I didn't really change anything. So think about it if someone gave you $5 and then they took it right back. You're at the same point you were when you started with. You're not plus $5, you're not minus $5, you're still breaking even. Or think about candy. If someone gave you 5 pieces of candy and then took 5 pieces away from you right away, you're still at the same spot you were at. So here's the thing, I'm adding this 25, but I'm subtracting the 25 from out here, so I didn't change the equation at all. But what I did is I gave myself a nice perfect square trinomial in here to work with. So now I'm on that step. And here's where you can stop and try to factor this if you want. You can do square method, you can do guess and check, you can do the product sum tables. But what I'm going to tell you is if you can use the shortcut, it's going to make life a lot easier for you inside the parentheses. So now I can take that shortcut and I'm going to say, what's the square root here of x squared? That's going to be x. I can take the square root of 25 and give me a 5. And because of this minus sign here, I know it's going to be x minus 5 squared. That's my shortcut. You can trust me on that one, or you can go factor it on your own, but it's going to be x minus 5, x minus 5 if you factor it. Either way, square method, product sum table. Okay? Or you can use the shortcut here and say I've got perfect squares here at x squared to give me x, perfect square 25 here to give me -5, and in the middle, I've got to make a -10, so it's got to be x minus 5 squared. That will always be the case. That will always be the case. Now, on the outside, you can't forget about this stuff over here. -8 minus 25 is going to give me a -33. Okay? So now I'm in a situation where I've got in standard form, basically, or I've got it back in vertex form. I took it from standard form to vertex form. Because if you look at what standard form is, I've got my y equals. Now I've got a times x minus h squared plus k. So if you look at it, basically my a value is here to be 1. I got x minus h here, and my k value is out here. So I've got everything I need. And it's x minus h squared, so I've got the square. So I'm in good shape. All right. So let's take a look at our stuff. I'm going to start with the vertex. Remember, your vertex, now we know, is always going to be h comma k. So I've got those things right here. I've got a k value and I've got an h value. So in this problem up here, where I use taking this stuff, this is my new vertex form of this equation. When I look at that, what's my h value? What's my k value? So remember, we have to forget about the minus sign. So my h value is 5. My k value is negative 33. So that would be our vertex. Remember, for the axis of symmetry, it's x equals h. X equals h, so it would be x equals 5 would be my axis of symmetry. Is it a maximum minimum? Well, it's a positive a value. Your a value here is 1. Remember, you don't have to write that. But your a value is positive, means it's open up. Since it's opening upward, we would have a minimum. Your y-intercept, that's where we go back to your c value right here. And your c value, your y-intercept would be negative 8. Your domain, of course, remember, is all reals. And the range, like we said, is a tough one. But let's look and see. You'd have to just sketch a quick graph of this. But the one thing we do know is, I'm just going to extend this a little bit with our range. The one thing we do know is if I did a quick graph, I know that 5, negative 33, 1, 2, 3, 4, 5, and negative 33, that's going to be way down here. That would be my vertex, right? And since that's a minimum point, that's why maximum minimum is important, your graph's going to be going something like this, right? So that's the lowest point. The minimum point down here is the lowest point. So for our range, it's everything that's going to be above negative 33. So for our range, we would write y such that y is greater than or equal to negative 33. Okay? And we put that in brackets. And we're good to go. Okay, let's try another one here. Let's go to number 3 here. X squared plus 15x in vertex form. Okay, so we're taking it from standard form to vertex form again. So I'm going to first write my a's, b's, and c's. That's my step-by-step process. My a is 1. My b is 15 because it's in front of the x. My c, there's nothing there. Well, remember, it's a plus 0. So my c value would be 0 here. Okay? So now I'm taking, I'm going to write it in standard form, x squared plus 15x, but I'm going to scooch my c value over, plus 0 here, and I'm going to put parentheses around the other stuff. So now it's trickier because obviously when we have an even number for our b value, then that's nice because you know you're going to get a even number when you divide it by 2 and you square it, you're going to get something nice. What if it's an odd number, like 1? 1 divided by 2 is 1/2, and then you'd have to square 1/2 and get 1/4 or 0.25. Doesn't really matter how you do it. In decimals or fractions, you're going to get something. Okay, so let's try one here. It's a little trickier when b is an odd number. So here we've got a 15 for our b value. I don't know why my mic keeps cutting out. So over here, my b value is 15. So I'm going to take my 15 divided by 2, and I'm going to get 7.5. Then I have to square 7.5. So it doesn't come out nicely, but whatever way you do it, you can still get an answer here. So now 7.5 squared is going to give you plus 56.25. So remember, that's where we're adding it in here. We're going to add it here, and we're going to subtract it out here. So 7.5 squared we know equals 56.25. So I'm taking that and I'm going to add it in here. And I'm going to subtract it out here. Okay? So now comes the factoring part. And this is where, if you try to factor it, it's going to get tricky with that 56.25. Or you can basically use the shortcut. And the shortcut's going to tell you that when we do this, we're going to get y equals. We know that x is here. And in this case, what is going in this problem here? Now, if you think about it, let's go back to two problems here. When we did this one, what went in this part right here? That was your 1/2 of b, right? We got that from right here. So 1/2 of b goes in to the parentheses. So when we fast forward to this problem here, 1/2 of b, your half of b value is going to go in here. Well, that was 7.5. So we're going to put that 7.5 in. I know it's plus because this sign is plus. So it's going to be x plus 7.5 squared. So dividing that b value by 2 gives us the number we put in the parentheses. So it's going to be a factoring shortcut. You really don't have to factor it and use any of the time to do square method or product sum table. You can just roll with it with x plus 7.5 because you already did that. Now on the outside, I've got 0 minus 56.25, so that's going to be a minus 56.25. And now I'm in a position where I've got it into vertex form. So already I've got this stuff here in vertex form. Hope you don't like that color. So this matches up my vertex form. So let's use the information that we have and fire it over on the right-hand side. So again, my vertex is h and k. Vertex is h and k. But you have to be careful with that sign. Remember, this is usually a minus sign. It's x minus h squared. So this would make this a negative 7.5 for your vertex. So you kind of have to figure out what you do there. Use the opposite or whatever works for you. But you're kind of ignoring that sign. The only way you can get a 7.5 is it was x minus a minus 7.5. So negative 7.5. And then your k value out here is your y-coordinate of your vertex, negative 56.25. Okay, maximum, minimum, again, it's a minimum because your a value is positive. So it opens upward, which makes it a minimum. Your y-intercept, we go back up to your c value. That's right here, is 0. Your domain, again, is all reals because you could pick any number for x. And now your range, we'd have to kind of look again at your vertex point. Remember, that's going to be the lowest point because it's a minimum. It's going to be the lowest point, so your range would be y such that y is greater than or equal to 56.25, negative 56.25. Remember, you can, it's always going to be greater than or equal to because it could be touching there, and actually is going to be touching because that's the vertex. Okay? That's our range. Okay, so we got a couple examples for you to work on. That brings us to the lesson summary. So our question here is, the first thing is, how do you know, where is it? How come I can't get it? Okay, well, it's not going to let me pull it up, so I'll just write it for you. The lesson summary is, how do you know what values add inside and subtract outside the parentheses? How do you know that? What is it? Okay? When you're turning it into vertex form. And the practice problem here then is write this in vertex form. We're going to write this in vertex form. Y equals x squared minus 2x plus 1. So take it from standard form and put it into vertex form. All right. That's it. I know it was a long one, but got a lot of information for you. All right. Bring questions, and let's go to work tomorrow.